Today is lecture number 2, the product types and engineering documentation. And we'll see what's the lettering rules and title block. Okay, so how to do title block correctly. The product types. When we talk about the product, we have to think about two things. The first is consumer products. We can purchase from the shop. All those things are consumer product, like the goods like watch, wristwatch, the clothes, car, pen. So similar to that kind of things are called consumer products. Okay. So other things which is not sellable, which is not can purchase from a shop. So but still you can purchase those things like business and industrial product. Those are material and parts. Like you can go to the some company and buy, for example, raw materials like wood kind of things, and by using that raw materials, you can make some kind of furniture. Okay, so furniture and some kind of manufacturing parts you can buy for your car from some company or from some special shop for car parts. Okay, so another things are capital items like the installations, equipment, the building. So those kind of things. Okay, so you can buy the buildings also. Those things also the product. Okay, so for example, construction, building something. The bridge kind of thing. So you can go there and you can install something. There is a equipment. It might be equipment, some rooms, some installations. All of those things are capital items. So you can use those items, those things, buildings, installations, equipments in your business, and you're producing kind of other products and which you're using in your business and producing a product. So also calls a product. Okay, so but it's not consumer product. Those are business and industrial products. And supplies and services. You can sell your service. For example, you might go to hairdresser and ask to have a haircut there. Okay, so he's giving to you a service. He's cutting your hair and you're paying money. Okay, so he's selling his service to you. So that is a kind of business and industrial product also. So those are products. So on last lecture, let's see the last lecture. Let's see the other lecture to remember, to refresh. Okay, so stop sharing, new share the lecture number 1. In previous lecture, we have seen the objective of the study, objective of the descriptive geometry, okay, technical drawing, about the graphic language, and the types of the drawings like instrument drawing, freehand drawing, or computer drawing, and also there was a description about the technical drawing, right? So I'd like to show you this one. So on last lecture, I introduced you about the product development life cycle. So every product should pass through this kind of similar to this life cycle. Okay, so started from the planning up to the manufacturing and production, and then selling and then support. Then new planning will start on. Okay, so similar life cycle should be done, should be passed through in order to produce any product, even though a building. Okay, so so now I'd like to go back to our own second lecture and continue. Okay, so
where I can find first lecture?
First lecture is already uploaded in the channel, in your own group channel. You can go there and download and see the video. Okay, so can you see the screen?
Yes.
Okay, okay. So I mute everyone. Then okay, continue. So product types, two types. The consumer products, those are clothes kind of thing, car kind of thing, pen. Okay, so and business and industrial products, those are raw materials, manufacturing parts, capital items like building, installations, equipment, and supply and services. Okay, so service, can hairdresser or kind of hospital service kind of thing. Okay, so so those are also business product. So the product types can be a different scale. Okay, so small scale or bigger one, the types are different. Okay, so here you can see the small scale products. The one of the small scale product, wristwatch. Okay, so watch is very small scale. It has very small scale parts, or electronic part devices like a cell phone. So inside you can see very small chips, electronic devices. Okay, so small parts. So the scale of this is very small. So that's why it's depend on the scale, the documentation, the drawings will be different. Okay, so I'd like to show the difference of the scaling. Okay, so different of the product types. Okay, so for the different type of the product, the items in product life cycle and documentation in each stage will be different. Okay, so that's why we start from the small one. Small is like a wristwatch or electronic small chips, small devices. And the second type is large scale products. So for your airplane, ship kind of thing. Okay, so the ferry is very big. It has very big scale, very big scale. So technique, the documentation preparation, the using of that documentation in the industry will be different way. Okay, so in this kind of product will be different. In this wrist kind of or phone kind of thing, the preparation of documentation, this kind of scale will be different. The third type is very large objects, like buildings, the bridges. So here you can see, and you can see that different. Okay, so different scale, very big scale. Even though in the map here you can see 1,000 kilometer to the 1,000 or 5,000 kilometer to the 5,000 kilometer. So here the terrain you can see. Okay, so different type of documentation will be needed in to build, to design, to build and servicing those kind of objects. Okay, so and what kind of documentation do we need during the PLM? Okay, so the during product lifecycle management, from the starting of the planning up to the building it and then servicing it. Okay, so so let's list. So you can see the listed things. So what kind of documentations do we need that during design something and produce those things? Okay, so we have to know, because of every stage has own drawings. Okay, so in the drawing, in technical drawing, we have to know those documentation, have to prepare those documentation, because those things are included in your future job. Okay, so if you get the job in engineering company or in industry or any mechanical engineering companies, related company, so those documentation, so you will work one of them. Okay, so it might be your work might be closely related to some of them, but not all. But so still you need to know what kind of documentations should be. At least this is minimum number of documentation, not all, everyone. So the first one is product design specification. We call it PDS. Called PDS. So before doing anything in the planning stage, you have to produce kind of PDS. Okay, so product design specification. What's the specification is? Product design specification is a statement of how a design is made. specify the design. You have to specify design. For example, when you get the homework, so I have to specify what you have to do in your homework, right? First, you have to bring a paper, A3 sheet, and then you have to bring a pencil, eraser. So you need to draw, okay, a ruler. You have to put the ruler straight and then draw with pencil and then do something. So I will explain everything in the beginning stage. So those kind of explanations should be included inside product design specification. Okay, so not for homework. This one is for manufacturing, for making something. Okay, so for example, car, for example, a furniture, for example, TV set, television. Okay, so in the beginning stage, you have to prepare this kind of specification. Okay, so explanation of what you are going to do and how you do and what should follow. Okay, so what kind of rules, what kind of requirements should follow, and how much you will sell this one, or how much you will spend for this one. Okay, so for manufacturing, and what will be the unit cost. Okay, so and what will be the profit. So similar to this kind of planning issues should be solved in this stage. Okay, so what is intended to do and how far it complies with the requirements. Okay, so those are product design specification. So, and for example, if you're a car producer, so and you'd like to produce a car, but you are not designing. Okay, so some design office asking you to manufacture of his designs. So there is one designer company, for example. Okay, so this is a designer company, and designer company, so design company. And here the factory. Okay, so that is a factory. Here the cloud. So that's the factory, the car factory. So a factory is only producing in mass production. Okay, so producing a lot of cars, but design company is designing only one prototype. Okay, so he's producing only design and making in the computer, and it might be prepared only 1-2 versions. Okay, so we call this one prototypes. Okay, so physical prototypes, and then he's giving to the manufacturer that one to produce many serial mass production, and then they're selling. So manufacturer usually requires from the design company PDS. Okay, so product design specification is requiring it. So PDS should be prepared from design company and then giving to the manufacturer, and it should be signed. Okay, so it should be signed, stamped. Okay, so with stamping, so it will be provided. Okay, a kind of documentation, and then manufacturer will follow these things. And then if something getting wrong, so if there will be some complaints like, okay, so that one is wrong, so you did wrong. So manufacturer will show this PDS documentation and then showing and then saying, okay, so I followed these rules, so no complaints to me. Okay, so go there and ask this design company. So because he prepared this PDS, okay, so this documentation, so and he did wrongly. So I followed the PDS and then I did it. You know, so don't blame to me, and don't say that I did the wrong thing. So I follow the PDS rules. Okay, so just go to the designer or go to the engineer who did the product design specification. Okay, so this kind of thing. And every time you have to ask from your client or your previous company that starts the business or starts the design or project. So this kind of specification. Okay, so this will help you. So similar to in your case, like students are saying, okay, so I follow the description of the homework description. Okay, so I follow the teacher's description, so I did this. Don't blame to me. So description is wrong, so that's why I did it wrong. So I did everything correctly, the teacher describes wrongly, so that's why I did wrongly. So similar thing. So how it looks like, let me show. So what will include is the product design and performance issues, like expected product size and weight. Okay, so product size and weight. So for example, in the car, so size should be 4 meter and the weight should be like less than 1.5 ton. Okay, so that is customer requirement. And expected product performance requirements, like voice of customer. So what will be the speed? So how fast should it drive and how slow? Okay, so it should be between this speed and between this. Okay, so how often we use this car? So if, for example, every day or once a week. Okay, so there will be different types of the requirement, like for the family car and for the supercar, like sport car. So continuous or discontinuously we're using it. So the loadings likely encounter, like what's loadings, like it can carry only 1 person, 2 person, or 7 person. So similar like that. Okay, so this kind of requirement will be included inside a PDS. So product power requirements. So power of the engine should be such. Okay, product shelf life. So how long we have to use it. Okay, so 10 years, 5 years. As you know, the previous cars were designed for very long time. For example, 15, 20 years, 30 years. So that's why you're looking at, in the street. So still they use in use, but nowadays our cars are designed for just for 10 years. So within the 10 years you have to sell it and buy a new one. Okay, so it should be recycled. Okay, so another thing is expected product service environment. What is the operating temperature range for this product? So the product designed for Uzbekistan and the product designed for Russia might be different. Okay, so in the Russia there is in the winter time it's very low temperature there, very wet. But in our country it's not such. Okay, so that's why the operating temperature is very important when you're making a PDS. Okay, so description. So what is the operating humidity range for this product? Subject to shock loading. How will the product be treated in the service? So those kind of things, okay, so included in the PDS. So expected product reliability standards and requirements, expected product aesthetics, so customer requirements. So the product designed as a kind of supercar or aesthetic car like Ferrari, and the product for family car or mini car will be different. Okay, so the requirement itself is set as very differently. So that's why their price will be different. Expected product maintenance requirement, possible of the shelf component parts, material requirement. What are the strengths of requirements? Like what kind of materials are you using? Expected if you have the budget, small budget, so you are using cheaper materials. Okay, so if you have big budget, you might use more strengthful material, more harder material or more expensive material. We can say not harder but more expensive, more you might optimize the weight and strength. Okay, so more better new material we can use. Expected products recycling potential and manufacturing process and the requirements and limitations. So those issues, you see, everything are A type. So in the B issues, those are customer-based questions should be included inside PDS. So who will buy this product? What's the market requirement? Okay, so who will buy? For example, if you produce nowadays, if you produce a Ferrari kind of car in Uzbekistan, so only 100% can buy this, okay, for the whole city. You cannot sell this one anymore. But if you produce very cheap car just for mini cars, it might be many clients might be purchase this one. Okay, so that is a who will buy this product. Okay, so for if you produce kind of car for for the students, for young people. Okay. So why you are producing this? Have you listed all potential classes of customers? So another thing are like who is buying this type of the product, what is currently selling, what's currently not selling. So competitors, like you have to make a benchmark, see and study who is competing with you, with your product in the market. So expected product distribution environment. Will installation require a professional, or just you can install yourself anything? Like can you replace the wheel by yourself, or you need a kind of professional? So those kind of things. In the C, the capability issues like company constraints on product design, manufacture, and distribution. What is our manufacturing capabilities? Can we produce this or not? Should we manufacture ourselves, or can we buy from other company or other country and then bring it here and just assemble the wheels and then sell as we did ourselves? So kind of thing. Okay, so nowadays, you know, the Malibu cars and some cars are manufactured as a outsourced company. Like they bring everything already manufactured, already assembled, but they assemble only wheels and some small elements, and then they're selling as they did themselves. And so schedule requirement, time to market. So they have to they have to plan the time to market and how long it takes from beginning to the manufacture and to the selling. How long? So 2 years, as you know, the former time, the long time ago, 15, 20 years ago, there was a lot of time required from the modeling, from the planning, from the modeling, design, and then to the producing and selling. Okay, 10 years, 15 years it took to make a car, but nowadays 2 years enough, 2-3 years are enough. So because of IT technologies are used widely in the car manufacturing, so that's why 2, 3, 5 years at least, you know, they can design and manufacture it. So those kind of issues. Okay, so here you can see the examples of PDS, like umbrella drying device, for example. The performance under specified conditions. The umbrella dryer must be able to dry a maximum of 4 umbrellas. So at any one time. Okay, so design drying system. What kind of drying time of the no more than 2 minutes. Within 2 minutes, it should dry the umbrella. Kind of a tool to dry the wet umbrella. When you come to home after using umbrella, it will be wet, so you have to put inside this kind of device, and so that will dry it up. Okay, so for the drying, we need 2 minutes, no more. So this kind of requirement. Okay, so must leave umbrella at least 80% drier. Okay, not 100%, but 80%. So power. power system shall be constructed to operate safely and conform to applicable standards. Okay, so those kind of saying. The power will be supplied using a common and mature technology, like home power can be used. So those kind of saying. So external body must provide ventilation, period of useful life, total life. So the umbrella dryer should last in excess of 3 years with normal maintenance. Okay, so you can use 3 years if you have good maintenance. So, and based on this, the producer will produce their design and they produce their product. Okay, so they choose a material for specific for 3 years. Okay, so their material can be used within 3 years, and after 3 years it might be broken. So they're choosing that kind of thing based on this document. So here you can see different types of PDS. Product design specification example. So product type mountain bike suspension fork. So the part of the bike, mountain bike, the purpose, features, easy to install. It should be lightweight, should remains rigid during cornering, affordable. It should reduce vibrations to the hand. Okay, so it should be used lasts a long time. Okay, so it should be used for a long time, 10 years, 15 years. Okay, so so competition. So you can list up. So what kind of technologies might be competing with this? So based on this document, then concept sketch we call ideation also. Okay, so in consumer products we need kind of the pictures, like a kind of drawings we call concept sketch or ideation. So normally it doesn't have any scaling. Okay, so no scaling that is there, so we cannot measure it, the dimensions. And it has a color selection, so you can see where we will be what kind of color. So and normally it shows a normal view, eye view angles. Okay, so those things. And another things, is bill of material. Okay, sorry, a research patent drawing. So after concept drawing, after preparing the concept, so you have to protect your product, okay, from others stealing, or idea should be protected from others, because other companies might use your idea to produce their own product and then selling instead of you know, in the market. So that's why you have to protect your ideas. So for that, we need to have a kind of patents. Okay, so to do that patent, so we need to prepare it. So how it looks like, we need to draw your idea, your product, and then with using kind of tags 1, 2, 3, 4, 7, 10, 100. So and then you can explain with the text. Okay, so it has a kind of drawing without any dimensions, and but with tags. Okay, so every part has a tag. So and you need to describe it in with 5-10 pages text description. So what we'll do, the first one, what's the second one? Okay, so this is kind of a patent of application of motorcycle stand. Okay, so motorbike, so there is a stand. This kind of stand is invented in 1916s. So that is this kind of documentation is made it patented in 1960s. Okay, so 1916s, August 22. So it's made it in this device. This stand is invented by H.T. Scott, so motorcycle stand. So he described everything with text and with graphically drawn thing. So one-page drawing with part number identification, bold tags or balloon tags or just tags. Okay, so this calls research patent drawing. Okay, so he is invented, and then he did the patent. So then he can sell this idea to other companies. Okay, so, and get money in case this is successfully used. Okay, or other company who is producing this one can buy from him this patent and then might be owner of this idea. Okay, so this kind of documentation might be needed in that stage. So in some cases you need a theoretical surface or outer shape surface drawing. Why you need how it looks like? Let me show you. So why you need I will ask you, for example. So this is a outer surface, theoretical surface drawing. Okay, so the outer surface of the fuselage of the airplane. Okay, so airplane outer surface is shown here, and so here you can see many points of the outer surface, and then the distances between from the front tip to the end, and then this every ribs are shown and distances in between the ribs, and then for example from the rib 8 to 13 or 13 to 33, from 13 from here, from here up to 33, all these cross sections should be like this, okay, this form. So, and shown with radius and another radius, and the radius will be written somewhere. Okay, so here. So you should follow this form. And after 33 and after 33 of 46 up to here, so all these cross sections should follow this shape. Okay, so similar thing. That is from the front view. That is from the front. That is from the top. Only 1/2 is shown because it's a symmetric shape. So that's why 1/2 also follow this these rules. So rules for outer contour, okay, drawing. So why we need this one? Why we need? How do you think? Why we need this one? Why such very okay, such surface, outer surface is important? How do you think? Why this outer surface to have to do not change outer surface is not okay? It's very important. Okay, so we don't exceed, we don't go out from outer surface. So the answer is the products like an airplane, like a ship, like a ferry, like a sport car, acting with air. Okay, so with air. So that's why if you change anything, something bump or something, so that will cause a more drag. Okay, so more drag, extra drag from the wind. Okay, so that's why the drag causes some kind of aerodynamic problems, or that will rise up the cost of fuel. Okay, so fuel will rise up. Okay, in the sport car you will spend a lot of fuel. That's why. Okay, so that's why they are optimizing this tip shape. Okay, so it's making kind of very aerodynamic. Okay, so because of it, they have to reduce a drag from the wind. Okay, so for the wind, so a lot of wind makes a lot of drag, big drag. So big drag to have a good performance you need to fire more fuel. Okay, you need to burn more fuel. So that's why they're optimizing the outer shape. So then they're going to inside. Okay, so they're designing outer shape and then they're designing inner shapes. Okay, so they need a water surface or kind of theoretical surface drawing. Okay, then we need an assembly drawing. Okay, assembly drawing. The assembly pictorial or assembly dimensions and tolerances, notes and specifications. So it has. So how it looks like assembly. For example, like this. 2D assembly drawing. So 3 views, as I told you, we have seen on last lecture. So the front view, that is front. That is front. That is this one is top view, and this view is from the left hand side view. Okay, so left view, left. Yeah. So left view is generated by from here. Okay, if you see from this side, if you see from this side, so this is an eye. So if you see from this side, you will see this. Okay, so normally it includes overall dimensions, but only overall dimensions, the biggest dimensions, and balloon tags or ball tags. So those are this kind of thing. Okay, so the part numbers 1, 2, 3, 4. For each part, they have a unique number. Okay, so for example, this part is first part, the outer part. The second part is this part. Okay, it's shown with point. Okay, so here, and then with tag, so tag, and then number. Okay, so second one. So and then third one is this part. Fourth one is another part. Fifth one is another part. Okay, so and then they have a part list. So part number. So first one, second, third. So here, first, 2, 3, 4, 5. So and then name of the part. Okay, so the first one is kind of, you know, the part number 1, part 1, or name of the part, like the body. And second one is some kind of wheel. Okay. The third one is kind of the shaft, the part name, shaft. And the number of the drawing, okay? So the number of this drawing means, so this is assembly drawing. So everything are shown as an assembly. But with this, we cannot understand how this part, only this part is done, how this one is made it. Okay, so it shows only assembly view. So we can see only how it's assembled together, but we don't know the single part, this only one part, how it's designed, or how is what kind of dimensions it has. Okay, so that's why we need another documentation. So that document will be, the number will be here. So for example, for the shaft, if we need to produce a shaft, so you can see here the number of the shaft, for example, the 3, so 3, and then go there, find a shaft name, and then in front of the shaft name there will be number. So go that to find this number, the drawing. Okay, so drawing with that number, and so that drawing show you the shafts, only shafts drawing. Okay, so with dimensions, with requirements, with notes, with every information about the shaft. Okay, so if you need to produce a wheel, Just go to the wheel and find a number and find a drawing with this number, and then that drawing give you all about the wheel. Okay, so in assembly drawings we can show only the view of assembly and how many parts it has, how many parts, and what kind of other drawing documentations are included to these drawings. Okay, so those informations. Another thing we need is bill of material. Okay, sorry, not bill of material. We need a assembly breakdown. By assembly drawing, we cannot sometimes understand well how many parts are together assembled. Okay, so but in assembly breakdown looks like this, So this calls assembly breakdown, and you can see here every part of this moved in outside from each other. Okay, so moved from far from others. Okay, so and you can see each part separately, and here also you can see the numbering: 1, part number 2, part number 4, part number 10, 6, 9, 5. Okay, so and also bill of material here. So this is bill of material similar to assembly drawing. So part number 5, the part name and how many required. Okay, so 1 item is required. So 2 parts are required. So 2 parts are required, like side plate. So those kind of information. So this calls assembly breakdown. So assembly done as a breakdown, like so this is assembly. So it's broken to many parts and many sub assemblies. So for example, this one is sub assembly, also can be broken to the many different detailed parts. So that is kind of breakdown. Okay, so this is big father, and then that is a children, and so this children has own children. Okay, so grandsons. So this is a son, and that is a grandsons. So son of sons, sons of the son. So similar to this. Okay, so kind of breakdown. That's also important thing. So what's the difference? What's a good point and what's a bad point of each of them? Assembly breakdown and just normal assembly. So in assembly breakdown, we can see easily, even though the engineer, the people might not be engineer and who is not having a technical drawing preparation can understand this. But the bad point is to prepare this one is more difficult because it's in 3D. It's difficult to draw this. But this one is easy to draw, easy to prepare this one. But to understand this one, you need to have good preparation of technical drawings. Okay, so you need to have a skills of technical drawing, so you can understand them. Okay, so so another thing, another part is engineering documentation is part drawings. As I told you, for each part we need a drawing, only single part drawing. Okay, so in the assembly drawings there are many parts. In the assembly drawings there are many parts. Okay, so here many parts shown together. But in here, in assembly breakdown, also many parts shown separately together, but as a breakdown. But in here, only one part. One part is shown with dimensions. Okay, so many in assembly drawing, many parts are shown together. In assembly breakdown, also many parts, but shown in 3D. Okay, shown in 3D kind of thing, 3-dimensional view, kind of isometric view, isometric view. But this one, it can be shown as a front view. We call 3 view. Okay, 3 view or orthographic view. Orthographic view. And in the part drawing, how it looks like. Let me show you how it looks like.